Good evening. So we are looking at trigonometry 2 today, follow on from trigonometry 1, funnily enough. So to start with, we're going to write this little acronym down, SOHCAHTOA. Now what is SOHCAHTOA? SOHCAHTOA is a way to remember the trigonometric ratios, how to remember the trigonometric ratios. Okay, so if you remember from the last video, if you haven't watched it yet, do go back and check that. The sine of theta is opposite over hypotenuse, the cos of theta is the adjacent over the hypotenuse, and the tan of theta is the opposite over the adjacent. Okay, so let's draw this triangle. So we've got this triangle. I've labelled the angle theta, which will be given to you in the question. The side lengths have been given. So the question is, what is the cos of theta, the sine of theta, and the tan of theta? So before we do that, what you should probably do is pause the video now and see if you can work out what the trigonometric ratios are looking at the triangle. Pause the video and we're back. So cos of theta. Cos of theta, well, looking at the trigonometric ratios, and the acronym is CA, so it's adjacent over hypotenuse. Now the adjacent side to theta is this side here. It's the one that's not the hypotenuse and it's next to theta. So that means, well, we know the hypotenuse is 10 and the adjacent side is going to be, so that's 8 over 10, which is simplified to 4 over 5. Okay, good. The sine of theta. The sine of theta, well, that is the opposite side. The opposite side is this side, because it's opposite theta, so that's 6 over 10, because the 10 is the hypotenuse. Simplifies to 3 over 5. And finally, the tan of theta is opposite over adjacent, so that's 6 over 8, or simplified to 3/4. Great. Okay, so what's interesting is that if I were to draw that dotted line there and label these sides 3, 4 and 5, so if I half all the lengths and I keep theta in the same place, the trigonometric ratios will be the same. This is a little sort of additional extension point. So because these triangles are similar, the trigonometric ratios will be the same. So that means that if the triangle is similar but much bigger, the ratios will still be the same. And this will actually allow us to find out the angle. If I'm given a trigonometric ratio, I can find out the angle. And in the next questions, this is what trigonometry 2 is really about, it's finding angles if we have the ratios. Okay, so if I draw this triangle, okay, we can see that this is a right angle triangle. Also notice how it's a Pythagorean triple. 5 squared plus 12 squared is 169, which is the same as 13 squared. Okay, so the question is, work out alpha. Work out alpha. So how do we do that? Well, the first thing we do is we're going to use some trigonometric ratios. Now you can choose any one you like, but let's say in the question we didn't have that 12 there. Now you could work out that 12 using Pythagoras, but we could just say, well, if we look at alpha, which sides do we have relative to alpha? Okay, which trigonometric ratio are we going to use? So we've got the opposite side, and we've got the hypotenuse. Okay, we don't have the adjacent. So which trigonometric ratio involves the opposite side and the hypotenuse? That's sine. So we can say that sine of alpha, is equal to the opposite over the hypotenuse, okay, which is 5 over 13. Sine of alpha is 5 over 13. So there's this function that we can use. It's and it takes the trigonometric ratio and it gives you the angle. Okay, there are two versions of this. Now if you're using the My Script app on your calculator, you're probably going to write arc sine of 5 over 13. And if you're using a more conventional calculator, it would be sine inverse of 5 over 13. Now these are the same function. You put in a trigonometric ratio and it will give you the angle. Okay, so to find the angle I do this. Okay. Okay, so yeah, this says if you have a trigonometric ratio, that use this function to find the angle. That's what we were talking about. So alpha is, when you do this in your calculator, you get 22.6 degrees. Okay, or 22.61986 degrees. So alpha, we can say, is 22.6 degrees to 3 significant figures. Okay, we should probably do one more to just see if you can do it on your own. So this is the same triangle as in the first part, just rotated. So let's say we've got those two sides, 6 and 8, and the question is find theta to 3 significant figures. So what you should probably do now is pause the video and see if you can do it yourself. Okay, so I've got 1 minute. I'm going to try and break the 7-minute mark. So which sides do we have? We've got the opposite side and we've got the adjacent side. We don't have the hypotenuse. So since we've got the opposite and adjacent, we look at our SOHCAHTOA and we realise that we're going to use TOA. Tan is equal to, tan of theta is the opposite over the adjacent. Okay? So if you weren't sure how to do that, you should pause the video now and see if you can continue. Okay, tan of theta is 6/8, which is 3/4. That's tan of theta. So what's theta then? What's theta? So if we write theta, we're going to do a similar idea to the first part. We're going to take the arctan of 3/4, or the tan inverse, depending on what you're using. So the arctan of 3/4, we put that in our calculator, and that gives us 36.7 degrees to 3 significant figures. Okay, that is how to find an angle given a trigonometric ratio. In the next video, we're going to be how to find sides if we don't have all the sides, if we just have an angle and one of the sides. So we're going to look at that in the next video. Thank you for watching.